Gentlemen, this is Miss Jermaine. Just coming at you with today's afternoon work video. We're looking at representations of linear relationships, okay? So we started this activity in class. Our warm-up, which is probably one of my favorite warm-ups that we do in 8th grade, was this glass activity. Like, for real, it's not even like super duper related to what we're doing right now, but I think it's kind of fun and it's a nice icebreaker to sort of get us into this activity, okay? And we were looking and we had to decide which container held the least, which one held the most, and then we watched that video that sort of went through and made the decision. So our learning targets for today, we have 2 learning targets for today. First, I can use patterns to write a linear equation to represent a situation. So we're going to be looking at some situations, and we're going to have to look for patterns in the representations of our data, and we have to write equation based on them. It's pretty cool. I'm excited. So we're using patterns that we see to write equations based on a situation. Next, we're going to be able to write an equation for the relationship between the total volume in a graduated cylinder and the number of objects added to the graduated cylinder. So this one is really focused on what we did in class today. This one isn't too much worked on this afternoon. So this is a super specific sort of learning target. We don't usually have learning targets that are this specific, but today we're doing it. Okay, so in this activity with the graduated cylinder, we had the activity where we dropped the marble in. Every time we dropped the marble in, it raised that water level a certain amount of milliliters. And from there, we had to first create a table with some of our data points for this. When I put 1 marble in, what was the volume in milliliters? When there was 2, when there was 4, when there was any number of them. Then we had to create an equation using the variables v and x. Then from there, how many did we have to put in there to get all the way to the top of the graduated cylinder? There were 2 ways we could have done that. So then from there, we plotted some points and created a line on here. And then we computed the slope, or we calculated the slope of the line by using these to draw in our slope triangle. Then we talked about what the vertical intercept was and what did it mean in the situation. Lastly, we looked at this equation right here and we answered some questions about it. How does this equation represent the equation that we saw today? So the total volume that was in the sphere, or the graduated cylinder, Miss Jermaine, was equal to 3, because each marble added 3, 3x, x stood for the number of marbles, plus the original 60 that was in the container. The V represented the total volume in the cylinder. The x represented the number of marbles that we added. So where do you see the rate of change in the equation? Our rate of change is that number that's attached to our variable 3. What does the 60 represent? It is that vertical or y-intercept, the amount of water that we started with in the cylinder. I know we did this in class today, but quick 3-minute recap of what we did in class. Kind of crazy. Then, on slide number 9, before we left class, we actually did the first one here, where we had to calculate the slope of this line using our coordinate pairs. And if we think about how did we do this in class, we did this by looking at, remember, we talk about slope as, so we talk about our slope as being equal to the change in our y values over the change in our x values. So if we're looking at an equation here, and we need to calculate the slope of this line, we need to identify the 2 y values in this equation. So the 2 y values are 9 and the other one in this first coordinate here is 3. We calculate that by saying the second y minus the first y. So this one would be 9 minus 3. And the change in our y, which is our x value is a 4 and a 1. 4 minus 1. And then we can say that's equal to 9 minus 3 is equal to 6 over our vertical change, our horizontal change, which is 3. So we can say our vertical change, or our change up and down, is our y values here. Vertical is our y's, and so that's 9 minus 3, which our vertical change is 6, and our horizontal change, which is our x values, 4 minus 1, gets me 3. So if I write that as my y, my vertical change over my horizontal change, that would be 3 over 6, or 6 over 3, Mr. Mean is a gooseball, 6 divided by 3, and we can simplify that to the number 2. Okay? So that's how we're going to do that first one there, is we're going to say change in y over change in x is written as vertical change over horizontal change, and we can say 6 divided by 3. Okay? So that was his first one here. So we can say that slope is equal to the change in our y values over the change in our x values, which is our vertical change over our horizontal change. Okay, so we're talking about vertical change over horizontal change. Okay, so it's my change in my y over my change in my x, the vertical change over the horizontal change. So if I'm calculating my changes in my vertical numbers here, that would be my second value here, 3.5 and 1.5. So that would be equal to 3.5 minus 1.5. And our horizontal changes would be equal to the changes in our x values, those first numbers, 10 minus 2. Okay, so if I were to calculate what that would be, 10 minus 2 is 8. 3.5 minus 1.5 is equal to 2. So my slope here would be 2 over 8. My vertical change, which is 2, my horizontal change, which is 8, and that would get me a slope of 2 over 8, which is equal to, no, Mr. Main meant to write 2 over 8, which if we use our calculator is equal to 1/4. Oh my goodness, look at that. So now what I want you to do is I want you to take 2 minutes right now to calculate what the slope of this line is going to be using this idea of change in y over change in x, my vertical change divided by my horizontal change, and you can use these boxes here to help you write that equation. I want you to take 2 minutes right now. Awesome, we're taking another minute and 30 seconds to calculate that vertical and horizontal change and then turn that into our slope fraction of rise over run. Vertical change over horizontal change. Now we're taking one more minute. Awesome, we're taking another 30 seconds, guys. What do we think? Creating the slope of this line. And another 10 more seconds. 10 more seconds. Awesome, ladies and gentlemen. So we're talking about our change in our y over our change in our x, our vertical change and over our horizontal change. If we're looking at this coordinate pair, remember coordinate pairs are in x comma y over comma up, right? So that vertical change is going to be those 2 second numbers here, 75 and 35. So this one's going to look like 75 minus 35 is going to get me that vertical change. Now, if I'm looking to find this horizontal change, that's going to be our first 2 numbers, the 30 and the 10. 30 minus our 10 is going to get me that horizontal change. So if I subtract 30 minus 10, I get 20. If I were to write this next one, 75 minus 35, I might need a calculator for this. You can use your phone. 75 minus 35 is going to get me, it's not focusing. It gets me 40. Yes, nice job. So my slope is going to be 40 over 20. Ooh, and if I think about that, and if I use my calculator and I divide 40 divided by 20, you don't even need your calculator for this, but you can use it if you need it. 40 divided by 20, it gets me 2. So the slope of this guy here is equal to 2 over 1. What? And we said our vertical change was 40. Our horizontal change was 20. And we write that as a fraction of 40 over 20, which we simplified to 2 over 1. Awesome job, guys. I know that one was a little bit tricky, but you guys are so fantastic. Awesome job. So now, here comes the tricky part. We're going to slip and slide down to slide number 12. So we are going to describe a procedure for finding the slope between any 2 points on a line. So this is where Mr. Main is going to do a little bit of talking. So the way that we calculate the slope, the procedure that we would follow would have to be, we would have to write a fraction, right, of our vertical change over our horizontal change over our horizontal change. Okay, and we can make that look like over or division by highlighting that word vertical, those words vertical change, and hitting the underline button. Okay, and we also know that that is equal to, so that is equal to, let's see what it's going to be equal to. So it's going to be equal to that, that y2, that second y value, minus my y1, that first y value, over or divide by my x2, the second x value, minus an x2 minus x1. And I can underline this baby by highlighting the y2 minus y1 and hitting the underline button. Okay? So when we're calculating our slope, we're thinking about it and we're following this procedure of vertical change divided by horizontal change. The way that we can calculate that when we're just given some coordinate points here is we can say that second y value minus that first y value over the second x value over the first x value, the 30 minus the 20. In the way that you decide which point is first, which point is second, you look at them just left to right. Which one comes first, which one comes second. Left to right, you read it like a book. Left to right, which one comes first? This one comes, so this is point 1, this is point 2, y2 minus y1, x2 over x2 minus x1. Okay, and if we're writing it based on these using these letters, we would write it as our y2, which is which letter? V. If you're looking at this coordinate, these 2 coordinate points right here, it's our y2 minus our y1. What's our y value in this second coordinate here? It's going to be v, and we're going to subtract from that our Y1, which is the letter T, and it's going to be divided by x2 minus x1. So in the second coordinate point, the x value, which is u, and from that we're going to subtract the x1, which is the letter s. And then remember, we write that as a fraction by highlighting the v minus t and hitting this underline button. Okay? So we're talking about x2 minus y2 minus y1 over x2 minus x1. Y2, the y value in the second coordinate, minus the y value in the first coordinate, divided by the x value in the second coordinate, minus the x value in the first coordinate. Awesome job, guys. I know that one was tricky, but you guys just did so great. Awesome job. I'm so proud of you. If you forgot how to do the underline piece, go back and watch me do it again, okay? I'm going to make this writing a little bit bigger for us because I want to make sure that we can really see it. Okay? So now let's look at this next piece here. Okay? So if we scoop-a-doop, I don't know literally where that came from, scoop-a-doop, slide down to slide number 14, it says create and interpret an equation for a situation with linear growth. Okay, for example, imagine you have a bucket of water that contains 10 liters of water, and you turn on the water faucet, which adds 2 liters for every minute. We need to think about, is this going to create a linear equation? Does it have a constant rate of change? Are we adding the same amount to the bucket every minute that the faucet is on? Think about it. Take 1 minute right now to think about, first, is this a linear equation? Does it have a constant rate of change? Is it adding the same amount every single minute? Yes or no? How do you know that? And then I want you to think about this equation. This is a little bit tricky, but I want you to think about this equation here. So I want you to take a minute right now. Actually, I'm going to say 2 minutes to tell me, is it a linear equation? And what would the equation be? Keeping in mind, I'm gonna write something for us. Okay, you're working while I'm writing something. Keep going. Okay, we're going to take another minute to first decide, is this a linear relationship? And then I want you to think about how you might write the equation for this story. Okay, we're taking another 58 seconds, my friends. Awesome, we're taking another 30 seconds. You're probably onto that equation by now. Start thinking, looking at this equation that I put in here. How can you write this equation for this story? Okay, so ladies and gentlemen, does this equation, does this story have a constant rate of change? So it has a 10 liters in its water tank, and then you're adding 2 liters every minute. So is this a linear equation? Yes, this is a linear equation. And the way that we know that is because it has a constant rate of change. The faucet is adding 2 liters every minute. Okay, so now we need to do some detective work, and we need to write this equation. Now, this is where we need to do some detective work, and we need to think about, and we need to look for some of those key words that tell us the different piece of our equation. So when we're looking at an equation, we always write it in the form, this year, we're going to write it in the form of y equals mx plus b. So y is that output value. Or in this case, we're talking about the total amount of liters in the tank. So we're going to start with that same variable because that y is a variable. And then we say y is equal to mx. And that m represents our slope or our constant rate of change. So I want you to think now that I just said that that m is written as our constant rate of change. Looking in this story, what was our constant rate of change? How much were we adding every minute to our container? Our constant, yes, you were right. That constant rate of change is 2 liters per minute. So we're going to write that as 2 attached to that x. So it's going to be 2x because for every minute, every x, we have to multiply the number of minutes that we're filling it times that 2 every minute. And then to that, we need to remember in that equation that we talked about up top in class today, we have to add to that our b or our vertical intercept. Or if we're looking at the story, how much did we start with? The bucket already contains 10 liters of water. So that means our vertical intercept is going to be that 10. So it's going to be written, the equation is going to be written as y equals 2x plus 10. That 2 is our constant rate of change. We always connect that 2 to our letter x. And then we have to add 10 to it. Oh my goodness, guys, you're so good at this. It's scary. Awesome job. So now let's slip and slide down to slide number 15. We're almost done. I'm so proud of you. So on slide number 15, we're given this equation. Oh, this is a little bit tricky. 10 is equal to, or b is equal to 10 plus 2m. What is the meaning of the 10 in this equation? So we have a 10 here and it's not attached to a letter. So what did we say that when we have a number that's not attached to our letter in an equation like this, that's going to be our y-intercept or our vertical intercept. So the 10 is going to be our vertical intercept. And where do we find that on our graph? It's the point where our line does what? Where does it hit that 10? Oh my goodness. So it hits that y-axis here. So the vertical intercept represents where our equation line hits Miss Germaine. Okay, so the vertical intercept, or that number in your equation that's all by itself. So when you're looking at the equation, when you have a number that's not attached to a letter, that's going to be your vertical intercept. That's called our vertical intercept, and it represents where our equation line hits the y-axis. Where does it hit this y-axis? At the number 10. Yes! Now, what does the 2 represent in this situation? So that 2 is attached to our letter. So that means that's our constant rate of change. And we said another word for that constant rate of change is that easy word. That's our slope, crazy. That is our slope. So the constant rate of change is our slope. And how do we see that on our graph? That's our rise over our run. Capitalize that word, underline that word rise so that you get it as a fraction. Rise over run. Oh my goodness, you guys are so good at this. This is scary. Awesome job, my friends. So let's take a look at this exit ticket for today. So the exit ticket for today is you are going to be creating a linear equation that has a slope of 3. So that means it has to have a rise of 3 and a run of 1. So every 1 you go over, it's going to go up 3. But it can't be a proportional relationship, which means it can't start at that 0, 0. So you are going to grab these points right here and you're going to put them anywhere, right? So you could put it here. And if it has a slope of 3, that means we have to go over 1 and up how many? Yeah, guys, you're going to go up 3. 1, 2, 3. Look at that. So I just created my equation line here. I put a y-intercept at 2, and then from there I went up 3 over 1, and I'm going to connect it to make my line. So I'm going to take the green line, I'm going to line it up with that y-intercept, and I'm going to pull it so that it goes through my second point that I drew there. Okay, and then it says, show how you know the slope is 3. So the way that you're going to show that the slope is 3 is by creating a slope triangle. So you're going to grab one of these little pink lines, you're going to straighten it out, you're going to create your slope triangle, grab a second one off the pile, line it up, drag it over, create your slope triangle, label your side lengths. It has a rise of 3, a run of how many? And then I want you to come over here and I want you to write the equation, remembering that you write it as y equals mx plus b. So I can't really help you out any more than that. You're trying your best. I want you to take 2 minutes tops on this and then make sure that you're done with it. And then once you're done with this lesson, guys, I need you to hit the turn in button. The last little bit that I want you to do, this is probably going to be my funnest one so far. I need you to send me an email with my code word. And today the code word is actually a code question. Do you believe in aliens? Yes or no? Send me an email. I believe in aliens. I don't believe in aliens. If you want to tell me more than that, you can, but I just want to know, do you believe in aliens? Yes or no? Awesome job, guys. I am so immensely proud of you. Reach out to me if you have any questions. I'm here this afternoon. If you want to join in to ask any questions this afternoon, that would be pretty cool. I will see you guys tomorrow. Bye. Stay cool. Stay lit. Boo!